Simplify by writing each result using positive exponents only. So we're going to use that negative exponent rule that we just talked about, which is any base raised to a negative power equals that base moved over a division bar becomes a positive exponent. So our first example, 3 to the negative 2 power. We're going to move that base 3 so that it has a positive exponent, and we'll need a number to hold the numerator's place, so that's going to be 1, and 3 squared is 9. Example B, the base of the negative exponent, it's only touching base x. So base x is, it has the negative exponent, needs to be moved so that it has a positive exponent. What about that negative in front of it? Well, that negative just stays in front, and that's negative 1 over x to the positive 3. Example C, the base of the negative exponent is x, so that base moves over a division bar and becomes a positive 4 exponent. What about the 2? It stays in the numerator where it already is. Example D, 1 over x to the negative 3. So x has a negative exponent. I'm going to move that base to the numerator. So that becomes x to the positive 3. And I really don't need that coefficient of 1. It's understood that that is x. That's 1x to the third. Simplify by writing the result using positive exponents only. So let's continue. The base of the negative exponent here is negative 3. So it moves over the division bar and gets a positive exponent. We need a 1 to hold the place of the numerator. So negative 3 times negative 3 is positive 9. Now this next example looks just like it, negative 3 to the negative 2. But what's the base of this negative exponent? Just the 3, right? So that base moves over the division bar so that it has a positive 2 exponent, and the negative just stays in front. So 3 squared is 9, making this a negative 1/9. Our next example, any base that has a negative exponent will flip over the division bar. So x will move to the denominator so that it has a positive 2 exponent. Y will move to the numerator so that it has a positive 4 exponent. Trick here is you can only move bases that have a negative exponent. If your base does not have a negative exponent, then it cannot move. Okay, so only bases that have a negative exponent will move over the division bar. If it was a positive exponent on either of those, they would have just stayed where they were. Our next example, we have separate terms because of the addition. That means separate. We're going to look at these completely separate. So the first term, it's got a base 5. So I'm going to move that base 5 so that it has a positive exponent. The second term, 3 has a negative exponent. I'm going to move that base so that it has a positive exponent. And I don't really need to put a 1 because it's understood that the exponent is 1 on those bases. So I want to add fractions, so I'm going to need a common denominator between 3 and 5. They don't share any factors, so the product will be the least common denominator. And that means I need to have a 15 in each of these denominators. So I'm going to be multiplying by the factor that I need to get a 15 in the denominator. For 5, I'm going to multiply by 3 over 3 to get 3/15. That's an equivalent fraction. For 3, I need to multiply 5 over 5 to get 5/15. That's an equivalent fraction. Now that they have the same denominator, I can add the 15ths together. 3 plus 5 is 8/15 altogether.